এই লিংকটা কোথা থেকে নেওয়া যাবে? লিংক দাও না, এই লিংকটা ওই যে কর্নার কর্নার, সবুজটা, সবুজ সবুজ। আচ্ছা, কপি লিংক। এই এই হচ্ছে এই সব নিয়ম। আমার এখানে খোলা আছে, আপনি লগ আউট করে নিচ্ছেন। তারপরে স্টপ হয়ে যাবে আবার সার্ভিস। কৃষ্ণ ভালো কথা বলেছে, সার্ভিস স্টপ বাস। কারণ আবার কেউ আর আসবে না, আর কেউ এইগুলো কোনো কিছুই কোনোটাই কাজে লাগে না, কেউ কারো কথা শোনে না, এটা হচ্ছে মেন ব্যাপার, সব নিজের ইচ্ছা মতো চলে। যা বলছে সেটা করবে, 2 মিনিট 3 মিনিট 5 মিনিটের পর ভুলে যাবে। এটা ক্যাজুয়াল গ্রুপ D1। ল্যান্ড ড্রাইভারও চাই, কিন্তু নেট চলছে না। আবার অ্যাডাপ্টার সেটিং এ যাবেন তো হোয়াইট হয়ে যাচ্ছে। পাইসিটা নিয়েছিল নাকি? স্ক্রিনের উপরে ওকে লাগা আছে, ওগুলো লাগাতেই হবে। আজকে ডেটটা কত? 4 4 গুড নুন এভরিওয়ান, শুনতে পাচ্ছেন সবাই? আবার শোনা যাচ্ছে?
হ্যাঁ স্যার, শোনা যাচ্ছে।
Okay. So today we are going to study pharmaceutics. About the drying part. What is drying and what are the types of drying? So drying is the process of removal of water or another solvent by evaporation from a solid, semi-solid or liquid material by the application of heat. When we will apply heat, then we will come to know about the filtration. So the final product after drying is dry, solid or powdered form. And drying is most commonly used in manufacturing as a unit process in the preparation of granules, which can be dispensed in bulk or converted into tablets or capsules. Dryer is a device that removes moisture by heating the mass to a level where it becomes safe to store. Now, in case of drying, for describing the three processes of operation that are simultaneously known here, they are as follows. Energy transfer from an external source to the water or organic solvent, that is direct or indirect heat transfer. And second phase or phase transformation of water solvent from a liquid-like state to a vapor state, that is mass transfer or solid characteristics. Next, if we move on to the third point, we can see that transfer of vapor generated away from the material and out for drying equipments. What are the importance of drying? What we will get from the drying process? It will help us to avoid or eliminate the moisture which may lead to corrosion and decrease the product or drug stability. To improve or keep the good properties of a material, example, flowability, compressibility, and etc. In case we can reduce, that means to reduce the cost of transportation of large volume materials and to make the material easy or more suitable for handling, to increase the shelf life of the product, thus act as preservative, and to act as final step in evaporation, filtration, and crystallization. Now, if we look onto the basic difference of drying and evaporation are summarized below, that is, main operation usually carried out on solid materials, example, powder or product. And in case of evaporation, we can see evaporation includes the removal of the large amount of water from solutions. Drying involves the removal of water at temperatures below its boiling point. The removal of water by boiling a solution. The product obtained is completely dried and more suitable. The product obtained is concentrated and needs further drying. In case of drying and evaporation, this is the basic difference between. Now, if we talk about the mechanism of heat transfer, we can see that first point is conduction. What is conduction? The transfer of heat from one part of a body to another without appreciable displacement of the particle is referred as conduction. This mode of heat transfer can also be called as molecular heat transfer because it involves the transfer of kinetic energy. Any type of kinetic energy can be transformed through this from one molecule to the one adjacent molecule to it. Example, conduction of heat along the length of a metal rod when one end is heated. If we talk about the convection, we can see that transfer of heat from one point to another in a body of fluid, such as a liquid or a gas, by a mixing process is referred to as convection heat transfer. In most cases, convection involves the transfer of heat from a solid surface to the bulk of the fluid. The change is in heat induced a change in the density of liquid. And in the other hand, we can see that as a body of radiation that transfers of heat by radiation system in the form of electromagnetic waves which travel in straight line at the speed of light and so on. And they are summarized as an example, sun and infrared heat lamps. If we look onto the equipments used for drying, we can see that various equipments are used for drying as shown in the figure 4.1. Dryers are of two types. Drying can be of two types based on heat transfer mode and based on mechanism. Based on heat transfer mode, we can say conduction, convection, and radiation. Example of conduction is fluid bed dryer, spray dryer, and rotatory dryer. In case of convection, we can see tray dryer, freeze dryer, drum dryer. In case of radiation, example, we can see infrared self dryer. If we talk about based on mechanism, we can see static bed dryer, moving bed dryer, fluidized bed dryer, and pneumatic dryers. In example of static bed dryer, we can say tray dryer, freeze dryer. In case of moving bed dryer, drum dryer. Whose mic is on? Whose mic is on? If we talk about the fluidized bed dryer principle, we can see that fluidized bed dryer works on the principle of fluidized. A process where a material is converted from a static solid-like state to a dynamic fluid-like state. In this process, hot gas or air is introduced through a perforated distributed plate into the area holding the material. This hot gas pumps through the space between solid particle. As the velocity of the gas or air increases, the upward force on the particle increases, causing them to equal the gravitational force below. This creates a state of fluidization where the particles are suspended and appears to be a boiling bed of liquid. Each particle is in direct contact with and surrounded by the hot gas or air, creating an efficient and uniform drying process. If we talk about the working principle of fluidized bed dryer, we can see wet granules to be dried are loaded in detachable bowl and bowl pushed into the dryer. Fresh air is allowed to pass through the pre-filter and gets heated up by passing through heat exchangers. The hot air flows through the bottom of the bowl. The fan at top is allowed to rotate. The air velocity is gradually decreased. When the velocity of the air is greater than setting velocity of the granules remain partially suspended in the gas stream. After some time, a point of pressure is reached at which frictional drag on the particle is equal to the force of gravity. The granules rise in the container because of high velocity gas and fall back. In a random boiling point, this condition is called as fluidized state. Wet particles are suspended in hot and dry air stream. Moisture on the particle surface evaporates as heat flow through the body. The rate of drying slowly increases as the particles absorb more heat. The moisture loss during the preheating is still small, but the temperature of the bed rises steadily. The bowler continuously draws and exhales air. Periodically, the bags are shaken to remove these fine particles. The residence time for drying is about 40 minutes. The material is left off in drying for some time and then bowl is taken out for discharging. The end product is free flowing. If we talk about the advantages, it requires less time to complete drying, that is 20 to 40 minutes compared to 24 hours of tray dryer. Handling time is also short. It is 15 minutes times faster than the tray dryer. Hot spot are not observed in the dryer because of its excellent mixing and drying capacities. It facilitates the drying of thermolabile substances since the contact time is short. It can be used either as batch type or continuous type. The free movement of individual particle eliminates the rise of soluble material migrating as may occur in static bed dryers. If we talk about the disadvantages of fluidized bed dryer, we can see many organic powders develop electrostatic charges during drying, which can be avoided by efficient electrical earthing of the dryer. The turbulence of the fluidized state of granules may cause attrition of some materials, resulting in production of fines, which can be avoided by using suitable binding agents. If we talk about the freeze drying, we can see here, freeze drying is a process of drying in which water is sublimed from the product after it is frozen. It is a drying process applicable to manufacture of certain pharmaceutical biological that are thermolabile or otherwise unstable in aqueous solutions for prolonged storage periods, but that are stable in the dry state. The term lipolyzation describes a process to produce a product that loves the dry state. The drugs which lose their valuability in the liquid state and readily deteriorate if dried in air at normal atmospheric pressure. This may be heated sensitive or they may react readily with oxygen, so that in order to be stabilized, they must be dehydrated to a solid state, and this is carried out by freeze drying, also known as lipolyzation, gestalization, or drying by sublimation. The dried product can be readily dissolved or resuspended by the addition of water prior to use of procedure known as reconstitution. If we talk about the principle of freeze drying, we can see the main principle involved in freeze drying is a phenomenon called sublimation, where water passes directly from solid state to the vapor state without passing through the liquid state. Sublimation of water can be taken place at pressure and temperature below triple point, that is 4.579 millimeter of Hg pressure. And the temperature similarly, the material that can be dried will be first frozen and then subjected under a high vacuum pressure to heat it, and then the frozen liquid sublimes, leaving only solid particles or dried components of the original liquid. Next, if we talk about the processing, fundamental process steps are freezing, vacuum, heat, condensation. There are the 4 steps. Product is frozen. This provides a necessary condition for low temperature drying. After freezing, the product is placed under vacuum. This enables the frozen solvent into the product to vaporize without passing through liquid phase, a process known as sublimation. Heat is applied to the frozen area product to accelerate the sublimation process. Low temperature condenser plates removed to vaporized solvent from the vacuum chamber by converting it back to a solid to complete the separation process. Freeze drying process, there are 4 stages to complete the drying process: pre-treatment, freezing, primary drying, secondary drying, and so on. Pre-treatment, it includes any method of treating prior to freezing. Methods of pre-treatment includes the freezing conditions, solute phase, concentration, and formulation of preserved product, appearance, formulation to increase the surface area. The objective of the freezing stage is to freeze most of the water originally present in the product for its Prostitute or sublimation. Primary drying. During the primary drying, the pressure is lowered and enough, and it is lowered to the supply to the material for the water to sublimate. When the water molecules sublime and enter the vapor phase, they also kept frozen product and again reduced. In this phase, about 95% of the water in the material gets prepared. This phase may be slow and high or rate because if too much of it is added to the material's structure could be altered. Secondary drying. Secondary drying is a process in which we can see that phase which aims to remove the unfrozen water molecule since the ice was removed in primary drying phase. In this phase, the temperature is raised than primary drying phase and can be above 0 degrees Celsius. Usually the pressure is given where we can filter it out eventually. And the phase of encouraged distillation after the freeze drying process completed, the vacuum is usually broken with an inert gas. In the periodic table, there are inert gases such as nitrogen, manage koro. Disadvantages, and if we talk about the advantages of freeze drying, we can now see product that have a few stability problems that can be stored in dry state. Product is dried without elevated temperatures and rapid reconstitution time, and constituents of the dried material remain homogeneously dispersed. Sterility of the product can be achieved and maintained easily. And in case of application of freeze drying, pharmaceutical companies often use freeze drying to increase the shelf life of the products such as vaccines and other injectables or the parenteral products that we use naturally. For the material of sealing and material of vial, the material can be easily stored, shipped, and later reconstituted to its original form for injection. In food industry, freeze drying is used to preserve the food and make it very light in weight. The process has been popularized in the form of freeze drying. Ice cream, an example of astronaut food, they are stored in fluidized freeze drying. Okay, now give the attendance. Obhibhushan, Anirban.
Present, sir. Anirban.
অভিভূষণ আছে নেই, অনির্বাণ আছেন, অনুভব আছেন?
হ্যাঁ স্যার, প্রেজেন্ট স্যার।
তারপর কে আছেন বলুন?
দামোদর চৌধুরী।
একে একে বলুন, একে একে। দামোদর চৌধুরী হোক, তারপর বাকিরা বলবেন।
49 দামোদর চৌধুরী।
দাঁড়ান, দামোদর চৌধুরীটা হোক, তারপর বাকিরা বলবেন।
सुभाषिस आचार्य जी।
दामोदर चौधरी, सुभाषिस आचार्य। दाঁড়ান, টাইম দিন। হ্যাঁ, তারপর বলুন।
বনমালী ব্যানার্জি 6।
বনমালী ব্যানার্জি, আপনাদের সাউন্ডটা খুব কম আসছে। বনমালী ব্যানার্জি, আচ্ছা।
সীমাবিদ।
দাঁড়ান, হয়নি এখনো, বনমালী ব্যানার্জি এখনো হয়নি। আমি নেক্সট যখন বলবো তখন বলবেন। হ্যাঁ, বনমালী ব্যানার্জির পর সীমাবিদ, তারপর তাওসিফ রেজা, তাওসিফ রেজা, তাওসিফ রেজা, আপনি শুনতে পাচ্ছেন? তাওসিফ রেজা, তাওসিফ রেজা, শুনতে পাচ্ছেন? তাওসিফ রেজা, তাওসিফ রেজা, তাওসিফ রেজা, where is your mic? Put on your mic. তাওসিফ রেজা, যারা যারা এখনো ড্রেসের মাপ দেননি, আমি ক্যাজুয়ালদের জন্য সবাইকে বলছি, যারা যারা এখনো ড্রেসের মাপ দেননি তারা কিন্তু অবশ্যই ড্রেসের মাপ দিয়ে দিন। তাওসিফ রেজা, আপনি ড্রেসের মাপ দিয়ে দিন। ওকে, থ্যাংক ইউ, আপনারা লিভ করিয়ে